All right, so the next section is about perpendicular bisectors, and angle bisectors. So we have a few theorems. So the first theorem is the perpendicular bisector theorem, and that says if a point is on the perpendicular bisector of a segment, then it's going to be equidistant from the endpoints of the segment. So we have this example here saying that PM is the perpendicular bisector of AB, and that MA is equal to MB. So therefore, if we were to draw lines from PB to B and P to A, then those two lines would be equal. Then there's also the converse, saying that if those two lines are equidistant from their endpoints, then if you were to draw a segment that is perpendicular bisector to the other segment, so we have in the picture PA is equal to PB, and then therefore PM would be the perpendicular bisector of AB, which would also make MA equal to MB. So we're going to look at this first example here. And so since we can tell that this is the perpendicular bisector, and we know that because QS is perpendicular to PR, and then we also have that PS is congruent to RS. So therefore, that means that PQ is going to be equal to QR. So we're just going to set them equal to each other. So we have 3n minus 1 equals 5n minus 7. So we get 2n equals 8 equals 6. So n equals 3. And then we need to plug back in to figure out what QR is. So we're just going to do 5 times 3 minus 7. So 15 minus 7. So QR will equal 8. The next two theorems we have are the angle bisectors theorem. So that just says that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So in the picture, we have QS bisects angle PQR, and SP is the perpendicular to QP, and SR is perpendicular to QR. So therefore, SP has to be equal to SR. And then we also have the converse, and that is just saying that if the point is in the interior of the angle, is equidistant from the sides, then that has to be the angle bisector. So in this picture here, which I know is a little hard to see, I'll move it up a little bit. We're given that CF bisects angle BCD, and then it's FB is perpendicular to CB, and FD is perpendicular to CD. So that means that FB has to be equal to FD. So we're going to set them equal to each other. So we get 6x plus 3 equals 4x plus 9. So we get 2x equals 6. So we get x equals 3. And then we have to plug back in for FB. So we're going to do 6 times 3 plus 3. So FB equals 21.